All right, let's go ahead and continue with our next section, 1.2, finding linear equations and functions. Our objectives are to work with point-slope form of equation of a line, parallel and perpendicular lines, linear functions, and linear applications. Linear equations in two variables. In the last section, nearly every question started with the equation asked for the graph. This section is simply the reverse question. Information about the graph of a line will be given and the question will ask for the equation. To recall, we covered the standard form and slope-intercept form, and this is the one we're going to use the most. What's great about the slope-intercept form is that we can easily pick out the slope and we can also pick out the y-intercept, which are two key features of a graph. Let's move forward with the question 1, example 1. Find the slope-intercept form of the equation of a line with slope -2 and a y-intercept 0, 5. So we have all we need to write this in an equation, right? Recalling from above, our slope and y-intercept. Notice that your slope is just the m. So we need to attach the x to let us know that that's the slope. The x is that little extra trick that lets you know what you're looking for. All right, so like we said, notice this question gives exactly the information contained in the slope-intercept form, y equals mx plus b. So let's replace m with our slope. Our slope is -2, like we see here. And let's replace our y-intercept with the 5, so a plus 5. If it would have been a -5, we would write -5. But plus 5, +5, we write plus 5. Contrary to example 1, however, there are numerous ways of describing lines that do not implicitly state the slope and y-intercept. For many of these questions, the use of a third form of the equation of a line is useful. So to recall, your slope is m and it equals rise over run. Now we have a formula to help us find the slope given any 2 points. And this is your formula of a slope, your definition. So make sure you have this handy. Y equals y2 minus y1 divided by x2 minus x1. Now, what are those small subscripts of 1 and 2? Well, they're referring to the point. So if we have a point 1, that would be x1, comma, y1. The little 1 lets us differentiate that, or differ to let us know that that's from point 1, the x and the y from point 1. Or if we have a point 2, which we'll need a second point, that would be x2, comma, y2. And that's how we can tell which y and which x comes from where, from point 1 or from point 2. And here we see that we use the y from point 2, subtracting the y from point 1. And in the bottom we have the x from point 2, x2, and we're going to subtract the x from point 1, x1. All right, find the slope of the equation of a line through 0, 1, and 2, 5. So we have 2 points. We're going to use our formula, and whenever you're working with something with a formula, write it down. It'll help you remember. All right, so we have our 2 points, our point 1 and our point 2. Let's go ahead and label our points. So we have x1, y1, x2, y2. The reason I like to label them is because then I can directly use my formula and I can just go ahead and plug in these values. So y2, we see y2 is 5. So I have 5 minus y1 minus 1. And x2, which is 2, minus x1, which is 0. And then we just subtract. So in the numerator, I have 5 minus 1, which gives us 4, and 2 minus 0, which gives us 2. 4 over 2, 4 divided by 2 gives us 2. There is no specific order to the 2 given points given, So example 1 could be calculated as follows. So even though we label our points 1 and 2, that's mainly to help us. If we wanted to, we could have labeled that first one to be point 2 and the second one to be point 1. And as long as both our x and y for each point have the appropriate subscript, we'll be fine. You just have to make sure you're being consistent. So in example 2, you'll see the same points, but in switched order, and you'll see that you'll result in the same answer. The calculation is the same regardless of the order of the points given or used. What needs to be remembered is the calculation of slope using y2 minus y1 over x2 divided by x1. Must have ordered pairs in the same position in each of the differences. For example, one point was given 2, 5, and the 5 can be first y value in the difference of the numerator as long as 2 is the first x value, the difference in the numerator. That's what I mean by being consistent. It has to line up with its appropriate point. Alright, here are more problems to work with slope. You have the answers there. You can go ahead and try them on your own. I want to highlight example 5. Find the slope through points 2, -1 and 2, 3. Alright, so let's label them. I always label them. It makes it easier for me. So I have x1, y1, x2, y2. We use our formula. Write down your formula. So it's y2 minus y1 over x2 minus x1. y2 is 3 minus y1 -1. In the bottom, I have x2, which is 2, minus x1, which is 2. Whenever you have a 0 in the bottom in the denominator's place, your answer is undefined. You cannot divide by 0. If we draw a line through these 2 points, we see that it's a vertical line. Every vertical line will have a slope that is undefined because every point on a vertical line has the same x-coordinate. Point slope for the equation of a line. Consider the definition for slope. Now, this is helping you derive point slope form. Let me jump ahead and give you the answer. This is point slope form. So we're going to be using a point. Let's label that x1, comma y1, and a slope, which we use for m. So our moving pieces that we're going to go ahead and start replacing are y1, our m, and x1. The x and the y that are not highlighted in red, those are just variables that would be in your equation. Recall the slope-intercept form y equals mx plus b. It can be easily used to find the equation of a line when the slope and the y-intercept are given. The point slope form y minus y1 equals m times x minus x1 can be easily used to find the equation of a line when the slope and any point are given. So the difference is here, the first one gives us our slope and our y-intercept. Well, if we do not directly have the y-intercept, I just need a point to give you an equation. We'll see this highlighted in example 6. Find the equation of a slope-intercept form for the equation of the line with slope 4 and through 2, -1. All right, so we have our equation. Always write down your formula, our equation. That's our equation. All right, now we're going to need our slope, which we have here. That's our m. We're going to replace m with that. And we also have our point. Remember, x1, y1. So let's do that replacement. Let's plug those in. So I have y minus y1 is -1 is equal to m. We said our slope is 4. Parentheses x minus, well, what is our x1? Our x1 is +2. So what we have highlighted is everything we replaced. We plugged into our formula. All right, let's go ahead and clean it up. So I'll do an extra step here. So I know a negative and a negative make a positive, so I have y plus 1 is equal to, let's distribute this 4. 4 times x is 4x. 4 times negative 2 minus 8. Okay, great. Now our goal is to get that y by itself. So we have to move that 1. That 1's a problem. So let's go ahead and subtract 1 to both sides. 1 minus 1, that's gone. 8 minus 1 gives us negative 9. So what are we left with? On one side of the equation I have y, and on the other side I'm left with 4x minus 9, which is our answer. As seen in example 6, the point-slope form is useful for finding the equation of a line given the slope and the point. In the next example, slope is not explicitly given, but enough information can be given to determine the slope. Example 7. Find the slope-intercept form of a line through 2, 5 and 0, 1. What's different here is I need to find that slope. So I need to develop the slope. And how do we do that? Well, we can use 2 points in our formula, right? The slope is not explicitly given, but we can find the slope using our formula. M equals y2 minus y1 over x2 minus x1. So let's go ahead and label our points. x1, y1, x2, y2. All right. Well, we could go ahead and plug them into our formula. So we get m equals x2, y2. Oh, they labeled them differently than we did. So let's go ahead and do that just for the sake of it matching. So they made this first one 0.1, x1, y1, and they made this first one 0.2, x2, y2. That way it matches the formula below. 5 minus 1 over 2 minus 0, and we get 4 over 2, which is 2. So this right here is our slope. We have one piece of the puzzle. Now let's just take a moment to highlight our formula we're going to use, and let's write down the pieces we're going to replace. So I'm going to plug in the slope, which we found is 2. Now I need to replace a x1 and a y1. It doesn't matter which point it is. It can be any point of your equation, or any points given. We're given 2 points. So how do you pick the right one? There is no right one. As long as you pick one of the one point that you use to find your slope, that's the correct one. So here you see that it's trying to emphasize that by showing you both ways. And if I can give you a hint, pick the one that has a 0. It'll make it easier for you. So I like this one more. And as always, you can go ahead and solve. So let's go ahead and work this out. So y minus 1, there's nothing to clean up there on the left side. I have 2 times x, that's 2x. And 2 times 0, that's 0, that's nothing. So we're left with y minus 1 is equal to 2x plus nothing. We want to get y by itself. So let's go ahead and move that 1 by adding it to both sides. That's gone, that's 0. I'm left with y is equal to 2x plus 1, which is the answer that our text says. The last example showed how slope was not explicitly given, but hidden within 2 points. In the next 2 examples, slope is hidden inside of the words parallel or perpendicular. Parallel and perpendicular lines. 2 lines are parallel if they never meet. In order for 2 lines to never meet, they must have the same slope. So think parallel, same slope. Example 7. Find the slope-intercept form of the line through 2, comma, negative 3, and parallel to the line 4 equals 4x plus 1. All right, so I want to create a line given this new point. And I want this line to be parallel to this equation, so I must steal this slope of 4. And so those are the only two pieces I need to find my new equation. Let's read our text. The slope of the desired line is not explicitly given, but the line known to be parallel to y equals 4x plus 1. Since the line equals 4x plus 1, the slope-intercept form, its slope can be determined to be by inspection as m equals 4. The line sought is parallel to this line and must therefore have the same slope, m equals 4. All right, so let's use our formula. Do you remember what this is called? Our point slope formula, because it uses a point and a slope. I have my point, and I also have my slope. So let's use those pieces of information. So I have y minus y1, which is negative 3, is equal to my slope of 4, parentheses x minus, our x1 is 2, close parentheses. All right, let's clean this up. We have y, a positive is positive, plus 3 is equal to, let's distribute, 4x minus 8. Let's move the 3 over by subtracting. So we have y is equal to 4x minus 11, which is what we have. All right, example 8 is very similar. I trust that you can go over this one on your own. Now, perpendicular lines, very similar. Two lines are perpendicular if they meet at the right angle. In order for two lines to meet at a right angle, their slopes must be opposite reciprocals. Opposite means different sign. So meaning if it's positive, change it to a negative. Or if it's negative, change it to a positive. And reciprocal means flip your slope. So if you had a slope of 1/2, change it to 2/1, which is just 2, and vice versa. So here we have some examples. If I'm given a slope of 2/3, its reciprocal would be opposite, so it would be negative, and we would also flip it. And you see all of them have opposite signs and they're being flipped. So you want to change a positive to a minus, and then you want to flip it. In all examples involving perpendicular lines, we find the reciprocal and change the sign of the slope to find the slope of any perpendicular to the given line. All right, let's go ahead and do example 9. Find the slope-intercept form of the line through 2, negative 3 and perpendicular to the line y equals 4x plus 1. So again, I have a point and a slope, so I'm going to use my point slope formula. But I need to change my slope a little. For it to be a perpendicular slope, I would have to change that 4/1. I would have to change it to a negative, and it'd be 1/4. All right, now I have my new information. I have a point of 2, negative 3, and I have a slope of negative 1/2. So I have all the pieces to find my equation of the line. All right, let's do so. So let's label my pieces, x1, y1, and I have my slope m. Let's plug them into our formula. All right, let's see what we get. We have y minus, my y1 is negative 3, is equal to my slope, and then x minus your x1, which is just the 2. Let's clean that up. A negative and a negative make a positive, so I have y plus 3 is equal to, now I must distribute, negative 1/4 times x is negative 1/4 x. A negative times a negative is positive. Now I need to multiply these fractions. Let me do this work on the side. I have 1/4 times 2, let's write as 2/1, you multiply fractions by multiplying across. So 1 times 2 is 2, 4 times 1 is 4. They can both be divided by 2, so this can be simplified to be 1/2. 2 divided by 2 is 1, hence the 1 in the numerator, and 4 divided by 2 gives us 2. So I have plus 1/2. All right, I subtract 3 to both sides, and I'm left with y is equal to negative 1/4 x. And to subtract fractions, we have a common denominator. Let's do the work on the side. I have 1/2 minus 3 over 1. That 3, in order to have a common denominator, needs to be multiplied by 2 over 2. So I have 1/2 minus 6 over 2. We multiply across. Now we have a common denominator. 1 minus 6 gives us negative 5 over 2. All right. I trust you can do this next example. You can go ahead and pause the video and work that out. Vertical and horizontal lines. So we talked about this a bit in our last lecture. We know a horizontal line has y equals a number, and a vertical line is x equals a number. A horizontal line, what's new is that a horizontal line has a slope of 0 and a vertical line is undefined. All right, so these next two examples are pretty quick. Example 11, find the equation of a horizontal line through negative 3, 1. All right, horizontal line is always y equals a number, right? And our point is x, y. Let's steal that y. So my line is y equals 1. Now, that's my little way of thinking about it. Let's do the way our text tells us. There are two approaches to this question. Approach 1, horizontal means slope of 0. So now we can use our point of negative 3, 1. We can use our point with our slope of 0 and our point slope formula. We work it out and we get y equals 1. Approach 2 would be like I said. Horizontal means the equation is y equals a number. In order to pass that point, y must take on the value of the y coordinate. So y equals 1. Find the equation for the line with undefined slope through negative 3, 1. All right, undefined slope. Did you see how our last question said horizontal line? Undefined slope is a very similar instruction. We see that vertical lines have an undefined slope, right? So would it make more sense if we said that this question is saying find an equation where the vertical line using that point, just like our previous example did? Yeah, it would mean the same thing. Undefined slope means a vertical line. All right, let's do it the easy way. So I have x equals a number. That's my formula for a vertical line. My x coordinate is negative 3. So therefore my answer is x equals negative 3. Again, what needs to be remembered is that if a linear equation being sought describes as vertical or as having an undefined slope, the equation will be x equals a number. If a linear equation being sought is described as a horizontal line or as having a slope of 0, then your equation is y equals a number. Let me highlight the same pieces above. So those are things that go in hand. Vertical line, undefined slope, that goes together. Horizontal line and having a slope of 0, that goes together. We can also see these problems. Let me highlight this. There are also examples that can involve vertical and horizontal lines along with the topics of parallel and perpendicular. Example 13. Find the equation of a line through negative 2, 5 and parallel to x equals negative 3. All right, so if I want it to be parallel, then that means same slope, right? Same slope. And I want it to be parallel to x equals a number. If it's x equals a number, let's go above. So remember, x equals a number means an undefined slope. All right, so it's going to be an undefined slope, meaning it has to also be a vertical line. So we're going to steal the value of the x. So I have x equals -2. That's our answer. 14. Find the equation of a line through 4, 1 that's perpendicular to x equals 2. All right, this is a vertical line. So let's think about it. It helps when you think about it for a bit. If we have a vertical line and I want to be perpendicular, it must be horizontal, right? So I'm going to have y equals a number over y. So 1. All right. You can go ahead and read the instructions there if you like. You can pause the video. Moving forward. In summary, parallel to a vertical line is another vertical line. Perpendicular to a vertical line is a horizontal line. Parallel to a horizontal line is another horizontal line, and perpendicular to a horizontal line is another vertical line. Moving forward, linear functions. When considering the slope-intercept form y equals mx plus b, the relationship between x and y can be stated as y being a function for x. For this reason, it is often useful to describe linear relationships using function notation. Any linear function can be written in the form f of x equals mx plus b, where m is the slope and b is the y-intercept, except for vertical lines that do not pass the vertical line test. Every line can be written as a linear function. All right, let's go ahead and take a look at example 14. Derive the linear function that can be defined to convert the temperature readings from Celsius as the x variable to Fahrenheit, f of x. All right, recall the 2 points will define a line. We will use the points derived by comparing the freezing and boiling points of water for both Celsius and Fahrenheit. All right, this question is very, very weird. So this is our question, right? Let's create an equation for Celsius and Fahrenheit. All right, so our answer is, well, let's create a point for Celsius that gives us the boiling point and the freezing point. Same thing for Fahrenheit, boiling point and freezing point. That way they're the same value, they're consistent, but they're different readings. All right, and there we have it. Now treat these as points. We have, since Celsius is an x variable, the 2 points are 0, 32, and 100 and 212. By using y2 minus y1 over x2 minus x1, which is our slope, we can create a rate. So a slope would be 9 over 5. Now I will need to use a point to find my equation. So I use my point slope formula, y minus 1 or minus y1 is equal to m times x minus x1 and your slope, which we found to be 9 over 5. All right, let's use a point that had the 0. So 0, 32. You will result with this equation. F of x equals 9x plus 32. And this lets us convert Celsius to Fahrenheit. All right, that's it for this section. We'll continue with next section for 1.3, quadratic functions and applications. If you have any questions, make sure to post them in our discussion board or email me. Thank you.